Hi there, this is Saxon Math, lesson 108, Algebra 2. Here is just more factoring, except for we have special cases. So we've learned how to factor a quadratic. Then we learned that when we had x squared minus y squared, that is a special case, and it's a difference. You see difference between minus subtraction between two perfect squares, and then how we factor is we just set x minus 1 times its conjugate, x plus 5. Now, if I had the sum of two squares, this is not factorable. That's not a special case. You can't factor that. So we're learning in this lesson the sum and difference of two cubes. So what is a cube? That is a cube. 27 is a perfect cube, right? Because if I take the cube root, I get 3. Isn't that 3 to the third? So you've got to be able to identify what perfect cubes are. So 8 is a perfect cube, 64 is a perfect cube, 125 is a perfect cube, y to the 12th. How do I know that this is a perfect cube? If you can divide it by 3 and there is no remainder, and it does, 3 goes into there evenly 4 times. So just like we said, this is the sum of perfect squares, and this is the difference of perfect squares. This one is factorable, and this one is not factorable. We also have the sum and difference of perfect cubes. So you're going to see the formula. So here's the sum of perfect cubes, and here is the difference of perfect cubes. And these are special cases, and they have a pattern on how to solve them, how to factor them. So and this is where you have to memorize what the pattern is. So you would take a plus b times a squared minus ab plus b squared. This is going to be a minus b, hence it's the cube root of the first term, the same sign, whether it's sum or difference, the cube root of the second term, times this squared minus the product of AB. Oh, and you change the sign to its opposite of the product of AB plus B squared. And that is what you have to memorize. And these are special cases. These are called sum and difference of perfect cubes. Now let's put this in place. So they want us to factor x cubed, y cubed minus p cubed. So the first thing I have to do, I have the difference. Look at term 1. Is it a perfect cube? Yes, it is. X cubed times y cubed. These are perfect cubes, and these are perfect cubes. So what I suggest, remember this is a cubed minus, b cubed. So we need to find what a is. By taking the cube root of the first term, it's x, y. B is going to be the cube root of the second term. You ignore the sign. You just take the absolute value. So that would be p. And the reason why I tell you that, because then you do a minus b, then you don't have to think about it as much other than knowing what the equation is. Now to factor it, I'm going to take a, which is xy, minus b times this squared. Remember, it's this squared, so it's x squared, y squared, because the whole thing is a, plus a times b, which is xyp, plus b squared, which is p squared. Now you factored it completely. Okay, so they try and go into this long process. Know the formulas. So instead, take term 1, take the cube root of it, take the cube root of b, and then you plug it into your formula. That's all you are doing. Let's try another one. So I'm given 8m cubed y to the 6 plus x cubed. Again, you ask yourself, is there any common factors? Is there any GCFs between term 1 and term 2? This is term 1, and this is term 2. Okay, this is A and this is B. No, there's not. So now I need to say, is this a perfect cube? Well, I know x cubed is perfect, so I know b is a perfect cube. Is this one? So I look at all the factors. 8 is a perfect cube, m cubed is a perfect cube, and y to the 6. So now I'm going to find what a is. I'm going to take the cube root, I'm going to put it in a light color. So I'm taking the cube root of this and the cube root of that to find a and b. So a would be 2my squared, right? Because if I take 6 divided by 3, I get 2 remainder 0, so it's y squared. B is simply x. Now, since I have the sum, so it's a cubed plus b cubed, and it's factorable to a plus b times a squared minus ab plus b squared. So now I just have to fill in the blanks, right? So a is 2my squared plus b, which is x. I'm going to put it down here because I'll have it. Well, actually, I can move this. Times, okay, so remember, this whole thing is a. So I have to square it. So that means this times itself 2 times. And when we do that, remember, that becomes 4m squared y to the 4th minus this times b. So that's 2m xy squared plus b squared. This is why you should always take the cube root. That way there's no question about it. Let's look at the last one. It said factor a to the 12th plus b to the 12th. So the first thing you ask yourself, are there any common factors? No, they're not. We have the sum, so are they perfect cubes? Well, they're perfect squares, but we don't have a special case for the sum of perfect squares. Are they perfect cubes? Yes, they are, because they're divisible by 3. So I need to find a is going to be a to the 4th, because I divide by 3. B is also going to be b to the 4th. Now, what's my formula of a cubed plus b cubed? It's going to be a squared minus ab plus b squared. Oops, I forgot the first thing, which is a plus b. That goes in the front. So let's go ahead and factor. And we've got, so we start with a, which is a to the 4th, plus b to the 4th, right, times, again, remember, I have to square these. This is a power raised to a power, so it's a to the 8th. So you have a to the 8th, oops, and we have to change the sign. So it's minus. This times 4, so it's a to the 4th, b to the 4th, plus b to the 8th. Now, if this was a difference, you could go on and factor this some more, but we can't. So that's simply our answer. It's not factorable any further. All right, so you got to know this is special cases, sum and difference of perfect cubes. All right, stop the video and do the practice and the problem set.